Hello dear children, welcome to Standard 8 Math class. Let us learn about shapes in our chapter Understanding Shapes. Today let us recall some facts of quadrilaterals. Here is a quadrilateral ABCD. What are A, B, C and D? Yes, they are vertices, the points at which sides meet. So vertex A, vertex B, vertex C and vertex D are the vertices of this quadrilaterals. Line segment AB, line segment BC, line segment CD and line segment DA are the sides of this quadrilateral. The line segments which form this quadrilateral. So side AB, side BC, side CD and side AD. There are two pairs of opposite sides in this figure. So AB and CD are opposite sides of this quadrilateral. AD and BC form another pair of opposite sides. There are pairs of adjacent sides in this figure. Four pairs of adjacent sides. AD and AB are adjacent sides. AB and BC are adjacent sides. BC and CD are adjacent sides. And CD and DA are adjacent sides. So in adjacent side, we will always find one common vertex. We will have four pair of adjacent sides in a quadrilateral. Like in AB and BC, we have B as a common vertex. BC and CD, we have C as a common vertex. CD and DA, we have D as a common vertex. And AD and AB, we have A as a common vertex. Also, angle A, angle B, angle C and angle D are the four angles of this quadrilateral. Angle A and angle C are opposite pair of angles. Angle B and angle D is another set of opposite angles. There are two adjacent angles to angle A, that is angle D and angle B. So angle A and angle D forms a pair of adjacent angles. Angle A and angle B forms a pair of another set of adjacent angles. So let us proceed into more details of quadrilaterals. Now we come across quadrilaterals everywhere in our real life, at our homes, outside, everywhere. Let us see different types of quadrilaterals. A quadrilateral can be a trapezium, a kite, a trapezium. So it can be a parallelogram also. Now we know about parallelograms. Rectangles, rhombus, square. These are parallelograms. And there are some other quadrilaterals also which are irregular quadrilaterals. So we are going to look into properties of all these in our chapter today. So let us look at the different quadrilaterals that we have seen. Yes, this is a rectangle. All angles 90 degree and opposite sides equal. This is an old friend. Also, a quadrilateral with all its sides equal. You guessed it right. It's square. In square also, all the angles are 90 degree. All sides are equal. Here also, all sides are equal. And opposite angles are also equal. Who is this? This is rhombus. All sides equal. Opposite sides parallel. Here is a parallelogram in general. Both of its opposite sides are parallel and equal to each other. Here is a trapezium. One pair of opposite sides is parallel. And the last but not the least, the kite. Adjacent pair of sides are equal. Now these are the basic properties of this quadrilaterals for which we have introduced to you. But let us look into more details of this quadrilaterals in this chapter. Now let us look at this quadrilaterals. Rhombus, rectangle, square. What do you observe about opposite sides of all these quadrilaterals? Yes, The opposite sides of these quadrilaterals, if you see, they are parallel to each other. Such quadrilaterals are called as parallelogram. We are going to look into the properties of parallelograms now. So let us prove the first property of parallelogram. We have here parallelogram LMON. According to the first property, opposite sides of parallelogram are equal. So in here, what we need to prove? LM is equal to ON and LN is equal to MO. That is, we need to prove. Now to do this, we are going to divide the given quadrilateral into two triangles using a diagonal NM. So we are having two triangles over here, and we need to show that the two parts of this triangle, that is LM is equal to NO and LN is equal to OM. You guessed it right. We are going to show that these two triangles are congruent to each other. If these two triangles are congruent to each other, then their 6 elements, that is 3 sides and 3 angles, become equal to each other. So LM will be equal to ON and LN will be equal to MO. Now we know various congruence rules. We are going to use one of them, like ASA, SSS, RHS. There are many rules by which we can show that the triangles are congruent. So first, let us write whatever drawings or constructions we have done on quadrilateral parallelogram. So proof: consider a parallelogram LMON and draw a diagonal MN to divide the given parallelogram into two triangles, LMN and triangle NMO. So now that we have two triangles over here, we have to show that any 3 elements of these two triangles are equal. If we show that any 3 elements of these two triangles are equal, then we can say that the triangles are congruent. So let us look for some elements of these triangles. Now if you see, it's a parallelogram. So the opposite sides are parallel to each other. So LM is parallel to ON and MN is a transversal. Do you see that in the figure? LM is parallel to ON and MN is a transversal. So we know that any two sides which are parallel to each other and there is a transversal, then the alternate interior angles are equal. Also, corresponding angles are equal, and also the interior angles are supplementary, that is 180 degree. So we know these rules already. So here we can see that we are having alternate angles, and we can show that LMN is equal to MNO. So we already got one element, that is angle. Okay, so LMN is equal to MNO, alternate interior angles. Do you see another pair of parallel lines over here? Yes, LN is parallel to MO, that is the other pair of the parallelogram, and MN acts as a transversal. Again here we can see alternate angles forming a Z. So again LNM is equal to NMO. Here again it's alternate angles. So now we have got two angles, two elements equal of these two triangles. We need only one. We can clearly see that there is a common side in these triangles. So MN equal to MN, common side. So we have got three elements, that is angle, these two angles, these two angles, and a side. So which rule can we use? Two angles and a side between them, that is ASA rule. So by this rule we can say that triangle LMN is congruent to triangle OMN. So if I flip these triangles, remove them and separate, LNM will be equal to OMN. So we can see that LN is equal to OM, LM is equal to ON, exactly the way we wished. So I've just separated the triangle to show you. So therefore LM is equal to ON and LN is equal to OM by corresponding parts of congruent triangles are congruent. So hence we have proved our theorem. Now let us see if these properties are true in rectangle, rhombus and square. Since they are parallelogram, obviously the property should be true for them. If it is a rectangle, Yes, we know that opposite sides are parallel. Also, in a rhombus, obviously opposite sides are parallel, and in square opposite sides are parallel. Now, are the opposite sides congruent, that is equal? Yes, in square all the sides are equal. In rectangle, that's a main characteristic of rectangle, that opposite sides are equal, and in rhombus also all the sides are equal. That means opposite sides are also equal. Now let us prove the second property. Opposite angles of parallelogram are equal. So if it is a parallelogram, its opposite angles will be equal to each other. Again, let us take LMON as a parallelogram and divide the parallelogram into two triangles. So we will show that the two triangles are congruent, therefore their 6 elements are congruent. So we will automatically get angle L will be equal to angle O, and we will also show that angle M is equal to angle N. So let us start with the proof. Consider a parallelogram LMON. Draw a triangle in ML. To divide the parallelogram into two triangles, triangle LMN and triangle OMN. We know that LN is parallel to MO. So LM is parallel to MO, and we know that MN is the transversal. So which two triangles angles are congruent? This angle will be equal to this angle, alternate interior angles. So we know that angle L and M will be equal to NMO, alternate interior angles. So one element is shown. Let us show the second element. We know that LM is parallel to NO and MNX as a transversal. So LMN is equal to MNO, again alternate interior angles. Now two elements are done, and we very clearly can see that the third element is the side between them. MN is equal to MN, so common side. So we know that triangle LMN is congruent to triangle MNO by ASA congruence test. So obviously its corresponding angles will be equal. Therefore, angle L will be equal to angle O. CPCT, corresponding parts of congruent triangles are congruent. But then how will we show that angle M is equal to angle N? Because angle N is a combined angle of angle A and B, that is LNM and MNO. And angle M is a combined angle of LMN and NMO. So we already have over here that LNM is equal to NMO. LNM is equal to NMO, and we already know that MNO is equal to MNO is here is equal to this triangle. So if we add this, as we know that angle N is a combination of these two angles, we will add it, and we know that this side also we have it equal. So what we do, we add equation 1 and 2. Okay, so adding, we will get LHS plus LHS equal to RHS plus RHS. So angle MNO plus angle NNM, that is LHS plus LHS, will be equal to RHS plus RHS. So if we see in our figure, angle L and M plus angle M and O comes to angle N, and angle LMN and M and NMO also comes to angle LMO. So here this will be angle N equal to angle M, and hence we have proved that the opposite angles of a parallelogram are equal. Now let us check whether this property holds for our other parallelograms like rectangle, rhombus and square. We already know that opposite sides are parallel, opposite sides are equal. Well, if you consider a rectangle, in rectangle you can see that the opposite, all angles are equal, that is 90 degree. So obviously the opposite angles are equal. If you consider a rhombus, in rhombus also you can very clearly see that the opposite angles are equal. So here they are acute and here they are obtuse. So opposite angles are equal. And if it is a square, then all angles are 90 degree. So obviously opposite angles are 90. So they are equal only. Let us go to the third property. Let us see the next property of a parallelogram. According to the next property of parallelogram, diagonals of a parallelogram bisect each other. That means in a parallelogram LMON, let LO and NM be two diagonals. Then one diagonal bisects the other diagonal in a way that LO LX will be equal to XO. So MN divides the LO by diagonal and XM will be equal to XN. So diagonals bisect each other in a parallelogram, and we are going to prove that. So we need to prove mathematically that LX is equal to XO and NX is equal to XM. So if we again consider two triangles LXM and NXO and show them congruent, then obviously their corresponding sides will be equal. So LX will be equal to XM and NX will be equal to XM. That is by flipping the triangles. So we will prove that these two triangles are congruent and hence the corresponding parts are equal. So let us proceed. First let us write, consider a parallelogram LMON and draw two diagonals NM and LO to divide the given quadrilaterals into four triangles. Now let us consider the triangle LXM and NXO because we are going to prove these two triangles congruent. So as we can very clearly see, LM is parallel to NO and MN is a transversal. So LM over here is parallel to NO and MN acts as a transversal. So LMX is equal to MNO, that is alternate interior angles. Also, we can see that LM is parallel to MNO, MN is a transversal. This time we will take LO as the transversal. So if we take LO as a transversal, again we are getting two angles as congruent, that is angle D and angle B, that is MLX and NOX. So these are congruent alternate interior angles. So first we took MN as the transversal and then we took LO as the transversal, and we showed that the two elements, that is angles, are equal in here. Now also if you see a side between these angles, that is LM and NO, they are equal to each other because we have already proved a result that opposite sides of a parallelogram are equal. So we will use it in this proof. LM is equal to ON because opposite sides of parallelogram. So by which rule do we get this congruent? Angle, side, angle. So by ASA rule, we can say that these two triangles are congruent. So obviously their corresponding sides will be equal and corresponding angles will be equal. So LX will be equal to OX and XN will be equal to XM. CPCT, corresponding parts of congruent triangle. And hence we have so easily proved this property also. Let us check whether this property holds for our regular rectangle, rhombus and square. We already know that the opposite sides are parallel, opposite sides are congruent and opposite angles are also equal, that is congruent. Now diagonals bisect each other. If you look at a rectangle, yes, the diagonals bisect each other. So if you see over here, this diagonal will be equal to this and this diagonal will be equal to this. In fact, diagonals of a rectangle are equal to each other, so they bisect each other. Rhombus, yes, diagonals bisect each other. And square, Yes, diagonals are equal and bisect each other. In rhombus, diagonals are not equal. One diagonal is longer than the other, but they bisect each other. In square and rectangle, diagonals are equal to each other. So here, diagonals are equal only in rectangle and square. In rhombus, they are not equal. Perpendicular to each other, that means the angle between the diagonals is 90 degree. Well, in rhombus, the diagonals are perpendicular to each other, and also in square it is true, but not in rectangle. In rectangle, if you can observe, here it is an obtuse angle and here it is an acute angle. So they are not perpendicular to each other. So these are some of the properties of rectangle, rhombus and square. Being a parallelogram, it takes all the properties of a general parallelogram. In addition to this, we can see that diagonals are congruent in rectangle and square, and diagonals are perpendicular in rhombus and square. Now let us move on to the next property, property 4, that is adjacent angles of a parallelogram are supplementary. Adjacent angles means angles beside each other. That is ln and angle n and angle n are supplementary. That means angle L plus angle n is equal to 180 degree. Similarly, if you take any two pairs of adjacent angles, then they will be supplementary. So if you take angle N and angle O, they are 180 degree. You can very clearly observe that this is obtuse angle, whereas this is acute angle. So they are supplementary. Here angle M and angle O are supplementary, that is 180 degree. Here also you can see that angle M and angle O, this is obtuse, this is acute. So total will end up to a straight angle 180 degree. Same with angle L and angle M, they are supplementary. That is, when you add them, you get 180 degree. Now, how do we prove this? It's very simple. So, one obtuse angle, one acute angle. When you bring them together, you get a straight angle. That is, the sum of the adjacent angles is 180 degree. And this is property number 4 of properties of parallelogram. This will be true. So, let us prove this property. Property 4 says adjacent angles of a parallelogram are supplementary. So let us consider LMON. We need to prove that angle N plus angle L is equal to 180 degree. Angle L plus angle M is equal to 180 degree. Angle M plus angle O is equal to 180 degree. And angle N plus angle O is equal to 180 degree. So to prove that, first let us consider a quadrilateral LMON. Now very clearly we can see that LM is parallel to ON and LN we will take as a transversal here. So if you see, these are interior angles in this case, and interior angles on the same side of the transversal is 180 degree. They are supplementary. So directly we get our result that angle N plus angle L is equal to 180 degree. What is the reason? Sum of the interior angles on the same side of transversal is 180 degree. So here we get a result, and hence we have proved it very easily. So similarly, we can prove it for L plus M by taking Ln as the parallel sides and Lm as the transversal. So we can take these two angles are supplementary. And we can also show further like angle N plus angle O. So this can be taken as a transversal and this as the parallel lines. So this is supplementary. Angle N plus angle O. And for angle M and angle O, this MO is the transversal and this are the parallel lines. So angle M plus angle O is equal to 180 degree. So this is a very simple proof by which we can prove this property. So in our chapter today, we have seen and proved some general properties of parallelogram. Have a nice day, children.